Okay guys, this is I guess it's part 4 of the RCA 17-inch that I'm working on. And before I get into recapping that board, and again just to remind, the reason we need to recap this board is because it's got a ton of these black bombs in them. So those all have to go. You know, we could run this set. We are getting deflection. It is working. We have sound. We could try to nitpick one by one, or go through the schematic and go through the sweep side, as you know, is this board mainly a sweep and sound combined. We could go through one by one and try to isolate which caps are giving us the problem, because certainly some of these caps are more important than the others. But again, if you're going to have to get into this board and remove this board from the chassis frame, you might as well just go ahead and do all of them. So that's what I'll be mainly doing and working on in this video, as well as starting working on the cabinet. But before I get into that, I just want to make sure that we check our B+ here, and that's what we're going to do now. We're going to put some power on it and fire it up, and we're going to check out on the meter. We're supposed to be getting 255 volts, and that's what we're going to be looking for here. So let me go ahead and turn on the set, and we can see if we're getting the right B+ voltage, which is really the lifeblood and the heartbeat of the set. And also, with all that power supply recapping that I did on the back side of this chassis, I just want to make sure that we're in the ballpark on our B+, because certainly the set will not run well without the proper B+. So right now we're at 199, but I have not heard high voltage kick in. So, oh yeah, we did. Yeah, we've got high voltage. Just wasn't paying attention, I guess. So we're 213 volts. That's down substantially than where I want to be. Let's see here. It's interesting that it hasn't topped out yet. Now, some of these caps could be acting like resistors in this circuit board. Certainly, I think there's a couple of open caps, and there's some bad ones in there. But it's interesting to just kind of sit here and watch. The B+ is climbing as the set warms up. So there's no old caps in here that could be reforming or anything. All the electrolytics have been changed. So I wouldn't think that would be what we're witnessing here. A lot of times, if you leave some of the old electrolytics in a set and it hadn't been played a lot, and certainly this one hadn't been played much at all, it's just been basically testing, you know, you can see something like that happen. I don't know. You still got a little bit here, but a lot of that's going to be corrected with changing some capacitors. Looks like I got horizontal going on here. Let's see if we can play with this a little bit. Looks like we're right at 233, which is acceptable. The set will play at 235 volts B plus. So yeah, okay, all right. So there'll be some change to this more than likely. We'll check it again after I get done recapping and we get the set operating correctly and get the right screen on it with the signal on it. Not too concerned about that, other than if it was way off. You know, some of the work that we did down in here in the chassis with the electrolytics, if that was way off. We were way off this number, you know, 190 volts or even 220 volts or less, or on the high side, I'd be really, really concerned. But with still a lot of work to do, I'm good with that. And that's still climbing a little bit. Interesting. But I'd say mid 230s. It's probably where it's going to stop after it warms up a little bit more. Okay. All right. Let's we'll get the picture tube out and just get the carcass of the chassis back on the bench, and we'll start attacking that wonderful circuit board. Okay, we're back on this 17-inch RCA portable set. I think this is part 4. Where we left off last time was I had finished recapping the underside of the chassis, the part of the chassis that sits closest to the picture tube. And the next thing that I was going to do was address the sweep circuit board and recap that board. We had a decent picture. We still had some fold over, and but we're close. We're close to getting a decent picture on this set before we started doing the recapping here. So I've changed about 9 caps since the last time we were looking at this. As you can see, caps here, here, and here. There's one, there's one, a couple down here, and one hiding back up under there. And the thing to note about this is it's really difficult to work on this board. These RCA sets of this design basically have this PC board soldered to a metal frame, and as you can see, that metal frame impedes a lot of access to the solder joints in the back, so involves a lot of unbolting and stuff like that. I did not remove any wires, but one thing that's a little concerning is there's still one black bomb cap right here. All right, if you take a look, you can see that this panel right here basically blocks being able to get to that cap. I was able to get to a lot of these other caps by unsoldering it, unbolting the whole panel, and pulling back on the circuit board, and with very minimal room, you know, get the solder iron in there and get the caps out and resolder them back in. So, you know, I was torquing on this board quite a bit, so hopefully I didn't do any damage and cause any crack solder joints on any of the other components that I wasn't working on. This one's a little bit troubling to me. I am not going to be able to get that out of there. We'll look at what that is in just a second, but what just really irritates the heck out of me is really the only way to get that cap out would be to unsolder the PC board, unbolt everything, undo every wire connected to this PC board, and there are probably 30 wires going to this board in some manner or fashion, and I'm not prepared to do that. And the other thing that's troubling is if you look closely, and this is the other thing that's problematic about this design, as you can see here, there's several ground points coming off the PC board to this metal frame. Here's more down here, and there's even more underneath this part of the board. So getting back in here and, you know, reconnecting that. Plus there's a couple of solders up here, right here. There's just a whole lot that could go wrong with that to change this one cap. I'm just baffled. What were the engineers thinking when they made this design? I know that they were scrambling to design portable sets in the late 50s, and being tube-based, that meant that room was at a premium. And so, you know, really the only way to incorporate this whole sweep board into the design of the set was to mount it this way. But I mean, if these black bombs, as we all know now in 2018, know that these aren't any good, back in the day, you know, they were replacing these wax caps, and we had the wonderful knowledge of time here, knowing that these caps actually, from a 50 or 60 year standpoint, were much better than these guys were. But my point is if this cap had gone out in this set within 2 or 3 years, taking this into a repair shop would require the same thing that I'm looking at to replace it, and that would be a total tear apart and would be quite expensive, I would think. I know I would charge a lot to do that. There's no way you can clip this out. It's an axial cap. You know, some of the ones that are laying down, you know, even RCA's service manual says, you know, pigtail, cut the component out and pigtail a new one in. Well, there's no way you can pigtail that in. You have to remove it from the board and insert a new one, basically. It's simple if you can get to it, but you can't get to it. One thing I thought about doing was I was going to practice on a like kind one like this and see if I could like chop this thing in half, or, you know, if I could just destroy it and leave these leads in there and pigtail a new cap on that way. But these casings are hard as a rock, really. The only way to get inside this is basically use a hacksaw. And then inside of this, there's metal. So I thought, you know, I had an idea. I thought, well, maybe if I can destroy the casing and take the insides out and just leave these leads. But those are even embedded in a really tough, almost looks like a melted piece of plastic. Anyway, it was an idea that wasn't going to work because there's very little room to work in there. So I basically come to the decision to just leave it in the set and see we can get away with not replacing it. Now, what is that cap? That cap is C18. And on the schematic, C18 is a coupling cap. It's a .047 coupling cap off of the video output tube, the 6AW8A. So I'm looking at this, and normally coupling caps can cause you problems if they're open or they're too leaky, but I'm not sure that this one's going to cause that much problem. My plan now is just basically leave this thing in the set, and we're going to put it back together, and I'll take you through that. As soon as we get it put back together, we'll do a fire up test. And it really, if it's going to affect anything, it's going to affect the contrast. And the last video, I had good contrast on the set. Now, it did cause some problems going through with its range of motion, but hopefully that won't be the case. If I do still have problems or have anything with the picture that I can't live with, then I'll probably do some voltage test on this video output tube, and make sure I've got that 0.8 right there on the grid. So yeah, I don't really like doing that. It's not, to me, a total restore means you're restoring everything and getting everything bad that could happen out of a set. These caps are notorious for leaking, and they're also notorious for shorting, and sometimes on occasion they explode. Actually, it'd probably be good if it did explode, and then maybe I could execute my plan to destroy it and tack something in its place, tap another .047 in its place. But yeah, other than that, everything else went pretty smooth, and didn't film all that because what we're going to do, we're going to put this thing back together. We're going to get the picture tube in it and fire it up and see what we get. So let's do that, and let's have some fun and see what happens. Okay, I've got everything put back together. Got the tubes populated. I've got power applied. Let's fire it up, and hopefully I didn't make any serious mistakes. And I see tubes lighting up. I hear sound coming out of the speaker. That's good. I hear high volt. I think I hear high voltage. Let's see here. There we go. Like I said, all the adjustments are way out of whack here. And looks like the yoke may be off a little bit here. That's okay. Sure what channel I'm on. Yeah, there we go. Okay. Turn that down a little bit. Put a signal on it. Alright, so we're not getting any video coming through. It's the contrast control, that appears to be working. Alright. Tight control, it gave me a full screen. Okay, so we got vertical. Vertical is really touchy. Looks like I'm getting some static interference. That's got to be the connection. Tuning doesn't really tune it out. Well, that vertical's really touchy. Huh. Yeah, that vertical is really touchy. Getting it to completely lock is kind of hard here. I got something going on with the connection here. Okay, that's better. I just put the connections directly on the prongs that the wire is on. I took that out. Now I'm not sure exactly what's going on with this switch. Could be dirty. I may need to clean this switch or this pot for.
By sending this telescope far enough into space, we can overcome the usual atmospheric distortion and get a much clearer picture of the stars and things.
Picture looks pretty good if I could just get it to vertically lock.
And this gadget here is a small television camera, which will also go along on the trip and send back pictures of what this little fellow receives.
That is really touchy.
Now, of course, this
That could be a tube too.
I mean, we have the problem of solar flares, the sun.
Or a resistor.
But I presume you've allowed for sufficient thickness to protect the satellite.
Oh, yes, of course we can.
And what is the weight of the total payload you intend to use?
About 2,000 pounds.
How do you plan to orient and control the telescope so that it'll track the star?
You seem to know quite a bit about this, Miss
Johnson.
Johnson. J.M. Johnson?
Mm-hmm.
Dr. Johnson?
Call me Johnson. Everybody does.
Call me foolish, everybody does.
Sorry, Mr. Douglas. It was an opportunity I couldn't resist. Well, shall we go to work?
Yes, I guess we'd better. Of course, this is the first time I've ever worked with an engineer who wears lipstick.
Yes.
I don't really know where to start.
Well, why don't you begin by briefing me a little.
Okay, you're probably getting tired of watching that. I'm gonna fool with it a little bit. It's still, I think I've got something the way it's set up that's causing that electrical interference. But let me fool with it a little bit. We're really close here. See if I can work on that vertical and get that static out of there. But picture looks good. Looks a lot better than it does on the camera.
Don't let those baby blue eyes hold you behind them before the show. Steve, if you've got any plans for Johnson other than business, forget them. Particularly a career one.
You know what we say, that
Yeah, let me work on that a little bit. I'll come back when I get it lined out. But yeah, we're getting there. Okay, so we're close on this RCA, guys. I wasn't able to get that rolling vertical to stop in the picture. The picture's looking great. We're really close on this thing, but just could not get that vertical to hold. And so I decided to break it back down and take a look back at the work that I'd done on the circuit board, because if you go back to I think it's part 3, before I ever began doing any work on this board, we had great vertical lock. It was nice and strong, and it was in the middle of the control, and vertical was the least of the problems with this set. So now why do I have a vertical hold issue? Well, there could be there's a number of things that could cause that. You could have a bad tube, particularly the vertical output tube. But unless that tube went bad because I changed some capacitors and a couple of resistors in this board, I highly doubt that that's the issue. What else could cause the problem? Well, you could have, since I made some changes with capacitors in here, that could have reset some of the voltages in here and thrown it for a loop. And maybe a resistor or two that was out of tolerance is not, it's not allowing it to work correctly. Certainly an open resistor could cause a big problem, but we had vertical, before I did the capacitor work in here. So really the logical thing for me to do, and what I have done, and I have found the smoking gun, was to go back and check and see if I made I put a wrong value of capacitor in a location. And that's exactly what has happened. So if you take a little look at this capacitor right here, this is C48 on the schematic, and I'll show you where it's at. C48, where is C48? C48's right here. It's part of the vertical multivibrator circuit. And if you take a look at this resistor value, it says 0.15, and it also says 10%. So what that means is the engineers have said that capacitor value is critical. It doesn't need to be outside of 10% of 0.15. If it is, if it drifts, or it shorts, or it opens, or gets leaky, that could cause a problem in this whole circuit, which could cause any number of problems with the vertical in this set. All right. This is a 0.1 microfarad 400 volt capacitor. That capacitor is a 0.15. On the parts description, it needs to be rated at 200 volts. So there's not a lot of voltage across that capacitor. That capacitor is not a 0.15. It is a 0.015. You can just tell by taking a look at the cap. That's quite a difference. That's way off. So obviously I need to get in there, remove that capacitor, and replace it with a 0.15. And if if I was a betting man, I would bet that's going to fix the problem. And here's the good news. All I really probably need to do is unsolder that point there, unsolder this point here, and I should be able to torque the board enough to be able to get at this capacitor and remove it, insert a new one. I'm just thankful it's not one of these in the middle, to where I'd have to really go back and solder a lot of different points. So yeah, no matter how long you do this or you're in this hobby, you can do something boneheaded like that and make a mistake. And but you know, that's the type of mistake that you'll be able to you can identify really quickly. And I did suspect that some of these resistors in the vertical circuit, particularly close to the vertical hold, might be bad or out of tolerance. I'm just not finding it. But what the real clue to me is that a couple of videos ago we had great vertical lock, and then really the only thing I did was replace some capacitors and a couple of resistors in the horizontal circuit, and then all of a sudden we don't have vertical lock. So I knew it had to be, more than likely I had to make a component change that was of the wrong value. And I think that's what it is. So I'm going to remove that capacitor, and when I come back we'll see if that fixed the problem and we can finally button up the electronics part of this set and move on to the cabinet.